Okay, so today I will talk to you about one of my part of my PhD project, which is on characterizing auditory, aversive, psychoaffective, and autonomic responses in tinnitus. So the auditory system is highly sensitive. Maybe you didn't see it, but there's a frog there, but you could have heard it, probably. But sometimes the auditory system is too sensitive, and some sounds can be really unpleasant, such as a baby screaming. And in some people that are stressed, for example, it can even lead to excessive behavior, such as the shaken baby syndrome. So what makes scream that salient? So if we take this sentence, "Oh my God, help me," and if we scream it, it will create fast amplitude modulations between 30 and 150 Hz and define a special range, the roughness range. The aversion is strongly correlated with roughness. And when we ask participants to perform a localization task, meaning saying if a sound comes from the right or left, they're more accurate when it comes to localize the sounds in the roughness range. So rough sounds also fasten behavior, such as when parents are running to their baby screaming. So our team has started to work with click trains for better acoustic control in the roughness range and beyond, and asked people to rate them from 1 to 5, 5 being really unpleasant. And what we can see, two things. First one, the aversion increases with the number of clicks per second because of an intensity effect, but also that aversion is stronger in the roughness range with a maximum of unpleasantness at 40 Hz. So the question is, how can we explain this behavior? And one first element of answer comes from data from intracranial recordings from epileptic patients. So I don't know if you can play the video, but this video actually shows the electrodes that are activating functional frequencies. And I don't know if you saw it, but what is interesting is what is happening at 40 Hz, where we have a huge synchrony in brain responses, and it appears that it recruits areas that are not only belong to the classical auditory pathway. So with that, we hypothesize that this linear part here is due to the processing of sounds up to the auditory cortex, but the classical auditory pathway alone does not explain entirely this behavior and this nonlinear part here, and this part is due to the recruitment of a salience pathway that is due to emotions and behaviors, and we would have this dual routine hypothesis model where the aversion is enhanced in the roughness range because of the recruitment of this pathway. And maybe in people with stress, this pathway would be hyper-excitable. So of course, we don't react all the same to sounds. We have people that are sensitive to rough sounds, other people that are not. Could be due to different in emotion, psychoaffective traits such as anxiety or autism, also how do we physiologically react to rough sounds, and finally to difference in brain excitability. So we thought about a model that could present an hyper-excitability to the salience pathway, tinnitus. So spoiler, we thought wrong, but tinnitus is the sound perception of noise without any external stimulation. And here we wanted to know if tinnitus were more sensitive to rough sounds, if psychoaffective traits such as anxiety and autism might affect the processing of emotional responses to rough sounds, and finally, if tinnitus alters autonomic responses. So we conducted a pilot study in normal hearing participants and in somatosensorial tinnitus, measuring EEG, EOG, and EKG. And the participants performed the task that I presented to you in the introduction, so the click trains rating, but at 6 different levels of intensity. And we measured also via questionnaires anxiety and autism spectrum quotients. So if we look at the behavior first in control, we can see that aversion increases with the intensity and is stronger in the roughness range. And the more we increase the intensity, the stronger the aversion in the roughness range is, which is not the case at all in tinnitus, where it's completely linear. So it seems that aversion is only driven by intensity. So they don't have this hypersensitivity to sounds, but we wanted to know if this would be explained by looking at psychoaffective traits. So we looked at anxiety scores and autism spectrum quotients. And in both cases, tinnitus exhibits higher anxiety and autism traits than controls. So they don't have this hypersensitivity to sound, but they do have psychoaffective traits that differ. And finally, we looked at a more objective measure, the heart rate, where you can get an idea looking at the frequency power in EKG at the activation of the autonomic nervous system. And we can see that looking at the power in low and high frequency, in tinnitus, we have a decrease of that power, suggesting maybe a reduced in sympathetic and parasympathetic responses to sounds that is maybe linked to psycho and neuroaffective traits. So we saw that normal hearing people present a nonlinear behavior in the roughness range, which is not the case in tinnitus. They are only sensitive to intensity. They present stronger anxiety and autistic scores and also reduced autonomic responses that is maybe linked to psycho and neuroaffective traits. But our population is really heterogeneous, so we really need to study this intervariability and try to link the behavior, neuronal and physiological responses to have a better understanding of how rough sounds are processed. So thank you for your attention.
Any questions about?
Thanks a lot for the wonderful talk. I have a question with regards to the roughness part and tinnitus. So people who have tinnitus often also have hearing problems, right? Suffering from hearing loss. So to what degree do you think this could be explained also just by hearing ability of the subject?
Yeah, that's also a problem in our population. We do have a problem with hearing loss, and they don't really hear well at low frequencies. Mm-hmm. So that's also a problem that we want to address in the next steps to really select tinnitus without any hearing problems, because that's a problem that we have also here.
Which is super challenging to find. I'm having the same trouble.
Thanks. Thanks. Any more question?
So very interesting results. I'm just wondering if you try to correlate the trait in anxiety or autism quotient with your non-aversive response to the 40 Hz to try to, interpret the data according to this psychoaffective process.
Yeah, that's true. We didn't try correlation yet, but that's something that we really need to look at to have a better idea and link behavior and psychoaffective traits.